Okay, be live here. Hi. A whole bunch of research I've been looking at. I want to go back today to this. Heck. It'd be fine. Okay, so this was the imitation result from before. It's kind of funny how this was immediately. It's like so much more promising than the off Paul, isn't it? It also did better than nothing on breakout. Okay, so I think what we're going to do is we're going to train an advantage function. And we're going to weight the loss by the advantage function. Let's see what that does for us. Welcome, Adrian. Gold stands for good. Like the actual good ones. Honestly, we can probably take a lot of this stuff, can't we? Yeah, really, I just need the, need this entire block. Okay, so we can do this on gold values. Boards. Fine. And I believe we already messed with... Yeah, so we already have the gold data. We can start with this, right? Ah. Gold is equal to advantage filtering. No, I'm doing imitation stuff, so it's an experimental. I should have probably clarified. I'm kind of tired today. Um, so what I'm doing at the moment, it's imitation learning without an expert. The idea is, you collect some data, you sort it to see what data is actually good, and then you just do imitation learning on the good samples with some weighting. I've been going through over the last couple days like a whole bunch of math, and it seems like there's a very close equivalence between behavioral cloning and policy gradient methods. It's just that the derivation that you get out of policy gradients assumes that your data is on policy. Behavioral cloning doesn't, but they seem like just different weightings of the same objective when you actually write it out. So I'm trying to see if we can break the need for the on policy assumption. Yeah. So I mean, this has been the main thing I've been trying to figure out um over the past several days is like, how do we drop the need for the on policy assumption? Interesting that this works perfectly. Math blogs, if any. Well, if it works, there will be one, right? I've seen that this is like a qualitatively different type of algorithm already. There's something here. So I know that we can get something out of this. The question is just how. Because I've seen some pretty crazy results already. But they're holes. Okay. Well, at least it's more stable here. There are a few different ways I can incorporate this, right? Let's get the prioritized sampling into this. Let's get the prioritized sampling. Okay, so you get the priority and you get an index. You have this absolute advantage here. Like this. Thing. You need to move to a harder task, I think. Yeah, this will be a better starting point. I don't know why it is, but like breakout seems the minimal task where if it works on breakout, it probably works on a lot of stuff. If you try stuff on Pong, if it works on Pong, it doesn't necessarily work on a lot of other stuff. Right, so this is our 20 whatever it is for. Do our prioritized sampling. What did I do wrong? Okay, so it's not a huge difference. Interesting. Go back to cart pull for a little bit. Should definitely do something. Okay, so yeah, this batch size is freaking tiny, right? Even have to be. This doesn't even have to be like this, right? We have a whole bunch of samples now, right? 5 mil. This should get slow. Yeah, so now this is super slow. This to 1. That gets you prioritized sampling. Possibly not very good prioritized sampling. Prio weights. Where's A? I need to come up with some values for this, right? Oh, so this MB prio actually doesn't even come in at all, right? It's just the index. You can just get rid of this for now. Okay. So this is still not weighting them yet, though, right? Hey, Dinesh. Weird exponential weighting, huh? they use for beta. .05. You're recomputing as well every time, no? What if we just did top K? Why not prioritize replay? You're literally looking at prioritize replay right here. It's hard to reason about, so I'm testing a few other things. You just do top K. Oh wait, should it not be absolute value? Maybe it shouldn't be absolute value, hang on. Yeah, it shouldn't be absolute value. This is why we need to just have a top K baseline. They used it with TD error. Yeah, because we don't have the one in Rainbow is like a 3-step bootstrap. So I've been doing a whole bunch of looking at the math, and the conclusion that I've come to basically is I think that a lot of these off-policy methods kind of just suck. Like the update that they do just sucks. But and the reason that it sucks is because they have like a very short bootstrap interval, and they get around it just because since it's on policy, they can just crank more and more compute into it. Because like, at least as far as I can see, how on earth are you supposed to get good updates out of like a 3-step bootstrap? And the 3-step bootstrap is already cheating because that's already off policy in a way that the algorithm, like in a way that DQN can't even tolerate. Like the only thing that actually should work is the 1-step bootstrap. Hey, convert. Automate homestead. Found another. What do you do for work that you're getting all the this land? That is awesome. Land is very good. I miss my my family's farm. I've been here, in Palo Alto for a bit. What's a 3-step bootstrap? All right. You guys can tell me if this is crazy or not, but I've been looking through tons and tons of math. So pretty much all the off-policies stuff does some form of this n-step bootstrap right here, this multi-step learning. Okay? But the thing is, they set n equals like 3. So instead of it being a literal one-step bootstrap, where it's just one state, like one reward, gamma max, minus q, whatever, you go forward a few steps. And now this data did not actually come from the policy. So technically, you should already have to importance sample this. But yeah. For a truck from Continental. Cool. Three-step learning is stops after 8. Yeah, so that's the problem, right? The reason that it stops after 8 is because it actually does break... It breaks the assumption of the algorithm, right? The reason DQN works for auth policy is that it's a one-step bootstrap. If you do a multi-step bootstrap, when you do like an n-step bootstrap like this, you technically are supposed to apply importance sampling to the data to correct, right? And here it's just, okay, you don't do that, but whatever, it's only 3 steps, so you don't get that far off. But then if you actually go look at importance sampling, like, if you go look at retrace, this is actually very, very similar to what I came up with for puffer advantage for the on policy case, okay? And like I said, you have to go through all this frickin' math, but the idea here is that you weight samples by the ratio of the probability of taking the action with the policy that you have now to the probability of taking that action with the policy under which you collected the data. So what this means is if these two things diverge a bunch, what's going to happen is you're not actually going to be able to make use of off-policy data because it's going to downweight everything. Like, it's a correction in the sense that you don't trust the data that's off-policy very much. Sequential, Monte, no? Okay, interesting. Um, get these baselines. Yeah, this is actually a pretty weak result for something this fancy. I do think search is the right way to go, though. Like, at least search is a reasonable way to go for scaling compute, I should say, when you have a slow environment specifically. How do you approximate the denominator? Oh, of importance sampling? You don't. You store it. Because you can get the probability of sampling this action, right, under the old policy, and then you're just using that whenever you use the new sample. Strong correlation between being fancy and being fake. Yeah. I mean, the problem with the off-pol methods as well is you kind of get it masked. So this is the best thing that I found, which is just like, this is basically Rainbow V2 in the sense that it's what happens if we strap more tricks. We just add more tricks onto it. And like, they get a pretty dang good result. I actually like this paper a lot more than the other ones. And it's like said, oh yeah, this is way faster as well than the other off-pol methods. But you do the math, and you're training Atari at like 2,000 steps per second. And the thing that I haven't seen from off policy yet, so I think that they are worse algorithms that are being made better by being able to leverage more compute on the same data. That's not what I want. I want to have like an equivalent algorithm that does just as well in the high data regime, but where you can crank up compute if you don't have as much data. You need to have this like smooth scaling between these two. Optimizing purely for low data regime is kind of just dumb. Okay, so this is a top K baseline. This gets stuck. That's kind of funny. Fast TD3. Yeah, I saw that. I didn't look at the details. Peter's lab. Okay, so this is pretty close to what I was wanting to look at here. Large batch training is good. Distribute if yeah, so this is what I was looking at yesterday. And one of the annoying things is you immediately have to do okay. Double Q. Where's the algorithm? Where's the algorithm description? Did I miss it? NDDPG. Distributional critic. Yeah, it could be that this is the way to go. I'm not sure yet. Well, that's some good evidence to have here, though. I'll keep on this for a little bit. I should actually do this up here, right? Oh, wait, can you even compute? You can compute advantage on this, right? Yeah, you can. And tell you. Okay, so we do something like this, I think. I don't know if I like the idea of throwing away data based on advantage or not yet. Think like this, maybe. Still worse. Well, we can kind of break up this problem a little bit, right? If I go to 20 million. Here, let's see, this is gonna be the full 20. Full 20 mil. And then, if we do the 32K before 4096, 8 batches. Okay, so that's not bad. Okay, 150. So basically no data should ever get kicked out here, right? Yeah, no data should ever ever get kicked out. IL segments. Sure. 8192 segments. That's totally wrong, right? Batch size. Oh yeah, this is just a mess up here, right? Something's free. This is just me having been sloppy. Okay, so no data is getting kicked out anymore. How do you start research? If you're interested in getting started on this type of stuff, my quick start guide, I made a guide for people. It's the most common question I get asked. So here's starter guide for programming in ML, and then for RL research specifically. Research and dev. The ML article also has some of my best advice for research in general. Right, so I break here. dot. Yeah, no worries. Uh, okay, this is probably horribly slow. Probably horribly, horribly slow. $150. So can I just train more now? Okay, kind of. It was unstable though, right? Why should it be unstable? Why can I not just do this and have it work? Okay. And just keep going up like this. What's wrong? Oh, you know what it is? It. You know if they're gonna release the RLC talks? No idea. I don't know if they're recorded, but mine is up on YouTube. I recorded mine separately. What happens here? Okay, so this definitely shouldn't be happening, right? You get your best indices. Oh, well, you're not optimizing a value function, dummy, so that would do it. Should be stable. Better. Okay, so you actually do get... You do get this. No positive advantage left. Gotta clip this somehow, right? Ah, okay. We have summed advantages. In some to-dos and evaluate, where you only stack observations from the same end but don't use mask. Wait, what do you mean you only stack observations from the same end? So that to-do is for something different. That to-do is for multi-agent like masking, or if you have like if you have dead agents basically. Truncations you could easily handle. I don't think any of our new ocean environments use truncations. You could handle it for classic ones though. I haven't bothered because like we just don't bother with in our new environments making a distinction. The main thing I'm trying to figure out at the moment is how to bridge this like gulf between like sample efficiency and compute efficiency. When you get done from an end view, keep stacking up. So that doesn't. So that's actually handled correctly. If you get a done from an environment, it gets reset. But like you cut the bootstrap. Like you don't keep incrementing values in your advantage function across done boundaries. That's already handled correctly. Downside of computer, what? Benefit of replay buffer. We're trying to figure out if we can have a replay buffer without having to use really janky off-policy algorithms that don't actually work in the high data regime. Just do it this way, right? Okay, so now we're no longer going to collapse on bad advantages, I suppose. No, we're definitely collapsing. How's that possible? Okay, I mean, so like you'll pretty darn quickly here get to the point where this thing is saying that there's just like almost no advantage left in the data, which seems weird. Because we're keeping all of the data around, right? You know, let's do losses, advantage. Let's put this in here. We can kind of see without having it spam us at what point this thing messes up. We start off high advantage. We're learning well. And then we get down to very low advantage and we regress. Code is kind of a mess, but the algorithm here, unless I have a major mistake, should be pretty simple. So we have all our rewards, observations, actions, values, terminals, right? We have everything. And we compute our advantage function. We sort it descending. Indices. And then we keep the best ones, right? And this is set up such that we really should not ever be throwing data away either. And we run a whole bunch of mini batches, which we compute our advantage estimate. Compute the advantage estimate, right? We take our top K samples. We just do IL. Right? We just do imitation learning. Same exact loss and everything. Oh, yeah. To this bot. this. No, something of this form I think should work. Advantages should be close to 0. Right, so when you've learned the task, the advantages should be close to 0. They shouldn't be before you've learned the task, though. And you definitely should not regress and, like, start doing worse when you're literally doing batch learning. About the number of samples surviving. That one is fair. But our losses. Why is it such a big number? Oh. For now, we'll just hard code. Huh. Yeah, this thing should be locked to, should be, like, locked. Okay. There isn't a Q function, though. It's just an advantage estimate, which is dependent on the current policy. So, if it shouldn't be able to get better than the current policy, right? Hmm. Having to fit the value function is No, this should totally work. There's got to be something screwy here. Yeah, so what I'm doing here, right, is I have fresh data being collected. For now, I have it set up so that effectively you're storing all of it, so you have access to all of the data. And then I'm just computing advantage, fresh advantage for everything. Well, as fresh as you can get it. And I'm just training on I'm just doing behavioral cloning on, like, the top 32K. So the idea is that you get all the information you can out of each of the samples. And I guess it is also possible... Well, the problem is you actually can't get a fresh advantage estimate, right? I think that's the problem. Yeah, you can't get a fresh advantage estimate without rerunning it on the whole batch. Like, you have to rerun the value function on the whole batch to do that. I can probably just code that up. It'll be slow. So we do something like this. We do this full forward pass. This will at least let me verify if what's happening is what I think. Oh. Move this out here. Slightly less often. Dude are gonna be out of memory. Come on. This stupid thing breaking. That's totally freaking wrong. How'd I do this? Still no? Okay. Much better. Still unstable, interesting enough. But we have positive advantage now, at least. Yeah, we actually have, like, good, reasonable data now. So we can figure out why this thing is unstable. Oh, this is gonna run the same frickin' batch 128 times, right? Oops. Yeah, this is totally gonna run the same batch. I don't see how the heck this is possibly still unstable. It's even worse, really. Really. Hmm. Hmm. I just want to integrate a value function with this thing. Why is this so difficult? I suppose I could do this on raw rewards first, right? Okay, let's do it this way. That's going to be super overfit, and that's still better. So yeah, there's something very screwy then about this advantage-based estimate. Like, this is literally just overfitting a batch of rewards. Okay. Let's just make absolutely sure we're not kicking out any data that we want. Now we are keeping data by reward. Get your new value function. Like, This doesn't do enough, right? Stability. Weird. If you just train based on reward, this works. Summed advantage. Very low positive advantage already. I think the policy thinks it should be doing very well. It does, right? Policy thinks it should be doing very well. Shouldn't be. But not for the purpose of sorting it. I think that would make a difference. Um, this is literally data selection because we're only using advantage to select data. So, I mean, literally, if I just do... Look how easy this problem is, right? If I just change this to gold rewards, literally just training on a mini batch of the highest reward segments. Which barely even makes sense, because you're like... You're gonna giga overfit. That actually solved before. Something changed. Hmm. Like a cheat. You can do it. this not solve a second ago? I could have sworn that we had this solving. We should actually then make sure that we can get this to solve, right? Otherwise... Okay. Good. So, sanity has returned. Right? So all this is saying is if you sample proportional to summed reward, you solve the task. If I do it this way, unstable. I think we absolutely do need the advantage function here as well, right? Like, the only thing that we really need to know is this segment better than the current policy or not? It's so hard about that. Be easy. Just read through this whole thing carefully. See if I've done something dumb. So you're just keeping... This means you're keeping all the data. The batch is like 20 million, so fine. You're updating your value. Fine. Get the value of everything in the buffer. Get your advantage. Values, rewards, terminals, ratio. Above, right? Same as here. Sum this. Same sample as before. Okay. Your value here. Again. Now this should work. Totally work. Suppose I don't understand why the value function is it the retrace thing biting me? I'd highly doubt that, but It's still unstable. How do you learn the actual value function? No, it's not implicit. It's right here. The clipped value loss, right? This is better. Doesn't, if I just do this on breakout, it doesn't work, right? Eh. Okay, well, slight problem with that. Can't have a 20 million buffer size. Should try to match the original sample efficiency, right? One. Okay. That is actually something. Is it amazing yet? No. It's something though. Ryan, we're doing behavioral cloning without expert data. Okay. Bad. Pretty much that, yeah. I'm trying to fit. The thing that's tough is you have to fit the advantage function to that to make it make sense. And I'm having trouble getting that to play nicely. I should probably just go steal the advantage weighting, right? Well, I suppose I haven't tried actually weighting it by the advantage yet, right? I've just done... You actually don't necessarily, though, want to get rid of segments in the buffer when they're at low advantage, right? Well, behavioral cloning, yeah. Work. I don't think that that works. So I did a whole bunch of looking at the math, and important sampling is just really stupid. Like, it pretty much just prevents you from learning on data because it's off policy. It doesn't actually help you learn on the data. It just like takes it out of the advantage pretty much. Yeah, but that's not what we want. I don't want to weight on policy data higher. I want to weight better data higher. Exactly. I'm pretty much like, I've been looking through so much of the off-pol literature, and it seems to me like these are just stupid, worse algorithms that are always going to be worse than the high data regime, and it's just that they spend a stupid amount of compute, and eventually it gets better than on policy, and then they keep going, and they can keep training on their stale data. This seems like it's why on-pol has been competitive in the first place, is because the off-pol algorithms are just fundamentally worse. Like, they do this really stupid, like, 3-step bootstrap or whatever. That's the main thing. And then even if you do something like retrace, right, it, like, kind of collapses to just being on policy learning anyways, just, like, with weird settings. Low data regime is more relevant to... I disagree. No, I completely disagree there. Industries do not give a shit if you solve their problem by getting more data, or if you solve their problem with a better algorithm. And fundamentally, having more data will let you learn better while spending less compute. Fundamentally addresses sample efficiency. I don't think it does fundamentally address the sample efficiency, and we have your author on the published paper for, like, the main candidate algorithm for that kind of crap. Like, I fundamentally don't even know if model-based RL makes any sense. You're literally training to, like, poke all the holes in your learned model. Definitely need data reuse. What to do with this? In expectation, changing sampling frequency should be the same as changing the weighting of the data. What the hell do we do with it? I don't like... So the thing that I don't like here, right? You're going to sample your good data more often, and thereby you're going to overfit it, and then you're going to kick it out of your buffer. Wait, high reward trajectories higher. Yes, that actually, well, it's the same thing, right? You can either, like, sample the high reward trajectories more, or you can weight them. Either of these work, at least for the simple environments. Just doing behavioral cloning on high reward segments works for simple tasks. The problem, right, is tasks where you don't have enough information just in that one segment. You need to, like, bootstrap an advantage estimate of some type, unless you're gonna wait all the way to the end of the episode, which technically you could kind of do with a lot of environments, but it's not ideal. Definitely not ideal. Yeah, so policy gradients does that. And this is the thing that I'm trying to figure out. If you actually just write out the math for behavioral cloning and policy gradient, it looks really, really similar. But, like, the derivation of policy gradients makes the on-policy assumption. Behavioral cloning looks very similar, but doesn't make that assumption. But, like, we know that you can't just run, like, policy gradient methods with totally off-policy data and have it work. So I'm trying to figure that chunk of it out, pretty much. Maybe you don't want an advantage function, right? Hang on. What if you just train... What if you just train, like, a bootstrapping value function? And then you keep the segments that have the highest, like, sum reward plus value. Isn't this kind of similar to what, I think I might have just recovered this other paper here. This thing. They weight it here, but yeah, this is reward. Probably this is, like, return or something. Value. No, this is advantage still. But what if we just do value estimate? I'm good at reducing increasing learning rate or clipping ratio. Well, not in our case, right, Ryan? Because we have a much more aggressively optimized baseline. So, like, if you actually beat our baseline on a bunch of M's, you should be pretty confident that it actually works. I think you do just want a value function, not an advantage function, right? Or do you want both? Well, hang on. You would still want to sample your data according to advantage, right? You just wouldn't want to kick it out of the buffer. I think that's right. Okay, so why does this not, like, insta-solve everything? Go here. We can mess with the sampling params on advantage here. Prioritizing data, definitely policy. You're not doing policy gradient. You're just doing behavioral cloning. So there are two different things here, right? One is, how do you select what data to keep in your buffer? You probably don't want that to be advantage based, because then if you learn a piece of data, you throw it away. You want to keep it around so you're building a good data set. But then how do you actually sample from that buffer? You probably just want to sample like high advantage trajectory segments, right? Because those are the ones that you can get the most information out of, but you don't want to kick them out of the buffer based on advantage. Because if you kick them out based on advantage, right, once you've learned them, that's it. If you kick them out based on low value, so which is summed reward over like some discounted reward or whatever plus the final value estimate, then you will not kick out like good segments. I guess your value function can still be wrong. So if you get too many super over optimistic ones, you can kick out other ones potentially. We don't have to do that just yet, though. We can kind of just chill on this for now. Um, let's do make this a mean first. One over beta. Exactly. Wait, you need rollouts for advantage? What do you mean you need rollouts for advantage? You need segments, and you have segments. You can refresh both of these estimates, right? Okay, so the sampling scheme actually definitely matters a ton. It's over 200 score on Breakout with literally just behavioral cloning. Can we find something that solves Breakout? parameter they had was 1 over 0.05, so it's 20. Yeah, that does by comparison. Now, I suppose the next question, right, is do you actually want to weight the entire segment the same? You know, maybe you're right, Ryan. Maybe the next step is literally to just say, screw it, we're doing on-policy algorithms with horribly off-policy data, but we're only going to use the best data, and we're going to hope it reduces to behavioral cloning. Right? I'll be right back. On-policy RL with horribly off-policy data. Of everybody calling me an idiot, I'm sure. Unless I actually make it work. I think the odds are 1 in 5. 1 in 5 odds of having this actually work, I'll say. Maybe 1 in 4. Being a little too harsh. Kind of a believer in that approach. So, like, the thing that I came across, right? The behavioral cloning objective and the policy gradient objective are not, like, fundamentally different. They're just kind of like different weightings of the same, like, log probs. So I don't see why we can't just try this and just basically say screw it, right? And then the idea is maybe on policy is like you're just trying to grab rewards from the data you have, which is going to be whatever the quality of the current policy is. And, like, obviously if you go reuse past old data that, like, you're better than, then that's not going to help, right? That's going to mess you up. But if you sample it according to advantage, doesn't this kind of make sense? Because, like, I've gone through so much literature in the past few days on off-pol, and it just seems like a shit show. It really just seems like a whole bunch of hacks tacked onto a really bad algorithm. And then you just spin up a ton of compute. Because, like, base Q learning works. I implemented it in Puffer, it works. And, like, technically, right, if you just run it for long enough on off-policy data, it should do something. But I think that basically they've just kind of tacked a bunch of things onto that and then run it for a really long time. Okay. Try this next. I gotta commit this. But my point is they're the same thing. Like, they're different weightings of the same objective, right? It's like literally just a log prob. It's just like grad, log prob, or whatever on both. For the critic, yeah. I think it's not entirely insane. I could be wrong, but I think it's not entirely insane. Where's our PPO update thing? I have to go grab a bunch of old code. Now we just do... Wouldn't it be funny if this actually ends up being the thing that works? Like, you have this whole other class of off-policy algorithms, and it's like, yeah, you kind of just don't do that. The likelihood of this being the case has gone up in my mind after talking to a bunch of people and, like, actually digging through a bunch of the math reasonably well, I'd say. Be legitimately mad. Dude, I'm gonna be ecstatic if this works, because it means that we'll have a super simple puffer implementation that just solves frickin' everything. I don't have to spend the rest of my life doing core RL research, right? If we just solve the field, I can find other problems to work on. Cool applications of it as well. Isn't this it up here? Oh, wait, so this is kind of it up there, no? So, like... log? And then you don't need the PPO objective either, right? Yeah, you don't even need the clipping of PPO. You literally just need then the... because the clipping is to keep you on policy. We're not doing that. We'll keep the gradient clip, right? Oh, literally it's advantage, right? Wait, where's... on. How the heck are you optimizing advantage? Wait, advantage... abs... some... Wait, how is this thing even differentiable again? MB... Just get back to NetHack. Very good. Hurry it up so we can actually get some cool stuff in. Is this actually differentiable? Confused. Yeah. It's not even differentiable, right? So wait, how the heck are we... It's stupid? Like, where's this loss even coming from? Advantage times ratio. Oh wait, log ratio. But isn't this 1? Times MB. Oh no, because this is a constant, right? So it's It's just new log probs times advantage. There. Okay, so that actually is a thing. And now can I put the full loss back? Okay, so it doesn't do anything meaningful. It is possible I've kind of just broken things too much, though, at this point. I'm kind of tempted to, like, start clean with this. Right? Yeah, I think we're gonna start clean with this. What I'm gonna do. And now I'm just gonna copy in the additional bits, I suppose. Yeah, I think easiest thing is to just keep the code that I have, like the gold data, and then just put this more cleanly back into do like this. This, and then basically don't change the eval stuff at all. And all I need to do this sort of a thing, right? At the top of train. let's say that for now we're just going to store by reward. Keep it simple. We'll just do to do store by turn plus val not. Right, so now we have our gold data. Then we'll basically do the exact thing that we have here, just with this different data. All right, so I need the defaults. Okay, so this is normal PPO, right? Yeah, so this is like our normal training. And then we literally just swap in gold. Okay, so this is pretty much everything. Pretty much everything in here. This needs to be set to Okay. So, that looks pretty stable. Now, obviously, it's not good, but this should be crashing everything, according to the on-Paul theory. So this is actually, I'm happy with that result. That solves part pull unstable. Does solve it. Okay, so well, now we have questions, right? See this. Ooh, break before this, huh? Okay. Fine. What's wrong with this? Oh, you know. Fine. This happened. Ah, see. Fine. This is it. This for now. Okay. Fine for cart pull. Nothing on breakout. Huh? Weird. Well, there's probably like, I'm probably not dealing with the empty buffer correctly, right? Go to like million-ish. Okay. Not stable. Interesting enough. Good plus, though. Makes it a lot simpler if we just sample based on reward for a bit, right? Like, can we literally just do... Also, this self-segment thing. Not terrible. Fine. Ah. Okay, still not stable, but They did something. Funny, because we know the clipping term is like super important when you're normally doing PPO. To do this. You want the log. This is insta-solve territory, right? End up with a 1. crashes. Starts learning. Thing enough. Negative? Why is it negative advantage? Oh, because you want to maximize advantage, right? No, hang on. Used. Are you able to explain the intuition for why you weight the geometric to lambda? So it comes from, I believe it comes from eligibility traces. Hang on. Where's this thing? Is it? Oh, here it is. Yeah, 287. Yeah, okay, so I don't know whether this is like the book was revised after JE. I don't think so. I think that this is older. Um, but you do get the lambda return formula here. So if you want the full math of it, it's here. If you want the quick version, it's just it's an exponentially smoothed average of exponentially smoothed averages. What's the exact shape of advantages? It's gonna have the same shape as the number. It's one advantage per observation, right? So if you have trajectory segments, like 512 segments of length 64, it's gonna be 512 by 64. A GAE looks like directly that to me, Kevin. I'm trying to figure out if we can get, and this is driving me crazy, but I'm trying to figure out if we can get on policy learning to work with off policy data, because it actually surprisingly kind of does in a few different settings. I've gone into a whole bunch of math lately that's convinced me that there should be a version of this that works. Log probs. I just do explicit cross entropy here. You just do explicit cross entropy, right? Completely off policy is the goal. The goal here is that we maintain a high quality buffer of data, and if we exclusively use that to train on, we should be able to bypass the on policy assumption because the math for behavioral cloning looks a lot like just a different weighting of on policy. We're kind of trying to push on policy learning towards instead being behavioral cloning of whatever data you have that's currently higher quality than your average policy quality. Hmm. Not using. So important sampling is the opposite of what you want. If you actually look at important sampling, it doesn't let you really use off-policy data. It kind of just throws away off-policy data. Speaking of which, thanks for the reminder. I did forget to disable the important sampling. I mean, I'm sure it's just getting worse and worse. Oh. Okay. Did learn for a moment. Okay, so you do have now the imitation loss, right? And bio. It's weighted by this. This one. Now it doesn't learn anymore. Rewards.sum. Just sorting segments by reward. And then sum. Remember, you're trying to get full-fledged PPO. Well, it's not really going to be PPO anymore, right? Because, like, the clipping term is for keeping your data on policy, so you're going to delete that. So you basically are just keeping the advantage function. Reinforced looks exactly like behavioral cloning rated by return, right? And then PPO, if you ignore the clipping, the other thing is it's weighted by an advantage function, right? And like there are algorithms that are based on like behavioral cloning weighted by advantage. The question is, if we filter our data carefully, can we get it to work like without expert data? Can we just like full bootstrap? I've seen like flashes of brilliance from like this type of stuff already. It's like definitely not insane. It's just like, is there a good version of this that I can figure out in a reasonable amount of time? Okay, so why the hell is that E plus? Oh, you probably don't want exp on that, huh? That probably breaks frickin' everything. Good iteration. Yeah, that's the goal. Is that what it is called? Expert? Well, except the fact that, like, you're starting with nothing, right? Wait, that's definitely not it. Hmm. Hmm. Was it one at every step? Huh. Funny. Literally just least number of falls. Kind of why sampling needed. I think the value function would fix this. Weird how I haven't been able to get... Like, the simplest thing I tried is the thing that I think has worked the best so far. But it has blind spots. Yeah, it's similar to that, right? I'm trying to do something pretty similar to that. Be the sampling thing, no? Great point. Okay. Keeping around the highest reward segments? What is this? Is it the frickin' advantage weighting that's messing me up? Hmm. Okay, so actually the advantage weighting is messing it up. If you just grab your high reward data, it works. What's the overall goal of this then? Well, I mean, what I would like to be able to do is I would like to be able to... I'd like to be able to get the same perf as my normal on-policy learning, but I'd like to also be able to use old data and thereby crank up compute and train more. I suppose the bit that's unknown, right, is like, well, you don't know, this should work. If you're taking your... If you're, like, if advantage weighted regression, it's basically the exact same objective as on policy learning, right? Basically the same objective. Like a negative sign flip. Not just like a dumb sign flip mistake, right? For some reason, waiting by the advantage like this. KL reg? PPO doesn't have KL reg in the clipped form. Welcome. I guess the question is why, like, every single advantage weighted form of this I've tried has not really worked. Oh, yeah. Why can't I weight this by... Oh, I wonder if it's the normalization being screwy. Reg. I don't know what the point of it would be. Have KL reg. You need it. You're not trying to, there's no on-policy thing to do. That this norm... It wouldn't be this norm, right? I mean, this is gonna mess up. It's still got GAE. I mean, that did something for a second. Too big, but, I wonder... I wonder if it's just the norm on it. It's a trivial policy. You don't want mean advantage at all. Can't subtract the mean. Divide by max minus. Yeah, that's not... I mean, that's not crashed totally, at least for a little bit, but that's not stable at all. Super obnoxious, like... Literally, if you just do this form of it... Yeah, this form is just IL on good, on high reward segments, right? And this works. Why do we still need an off-policy buffer? Two reasons. The goal is, one, so that we can actually do sample efficiency if we want to. We add that capability to Puffer. And two is that exploration is really hard when stuff is really sparse when you don't keep around data. Hey Spencer, what's up? How's off policy land? Hard. Taking top K leads to no stochasticity. Yeah, I've tried top K a whole bunch and it never works. Switch to sack? No. I've been looking at a lot of the off policy lit, and I really think that it's just the case that the algorithms all suck. They let you reuse samples, but they suck. So like I could be wrong, but here's an experiment for anybody who wants to. If you have some off policy implementation that you have, try to get it to match wall clock time with Puffer on anything. Because as far as I've seen, it seems to me like it's just a bad algorithm that you crank compute through. But you wouldn't want that, right? You want the same algorithm that does, in the case where you have a lot of data, it's fast. In the case where you don't have a lot of data, you can spend more compute to still learn. Like switching to this SAC doesn't do really anything for us. I've tried several things, Spencer. We're doing absolute advantage, or we could try just no. So right now we're just doing. We were having so much trouble with advantage that right now this is just reward. The thing that does consistently work, um, is just doing imitation on high reward segments. Like that actually works. Now the thing is, it's probably not going to ever be as efficient as weighting by an advantage estimate, because when you just do high reward segments, you're treating the whole segment as good. Cause and negative reward. No, I think right now we're just doing high positive reward. I mean, for breakout, it's negative wouldn't even do anything. That wouldn't make a. That doesn't even give you anything. I'd like to know why weighting by advantage breaks everything. Shouldn't it be... If I do... Isn't it positive advantage times mean? Yeah, because it should be positive advantage times mean with no norm. Oh. Heh. Okay. Still not super stable, but that's something, right? Learn the value network with the standard algorithm. And use that. Wait, you learn the value network with the standard algorithm. We do have the standard, right? The standard value net is just going to predict returns. It's the exact thing we have here. It's a clipped value function loss. Good value network to compute advantage here. You mean learn? What does it mean to learn the value network with the standard algorithm? I think that's what I'm doing. I had a negative sign because it's negative log probs or whatever. So I had a negative here because they changed the objective. I mean, this is kind of something. Is this consistent? Yeah, that's consistent. Okay. Shouldn't it be negative, though? I don't think so, right? For imitation learning, it's advantage times the behavioral cloning objective, right? I think it's not negative advantage times ratio. I think it's supposed to be the actual losses advantage times negative ratio. Isn't it grad of like negative log prob or whatever? The clipping definitely doesn't make. Get rid of this. Final value network. Yeah. Right, so that's why I didn't filter based on advantage. I filtered based on reward, right? For up top. I suppose that is the next thing would be to sample based on advantage. Okay, similar to before. So we can sample based on this. What happens if I do cart pull? Solve. Kind of janky, but yes. Oh, you know, we do actually remember. Hang on. Advantages get stale, right? Liked your post on learning programming in ML. Thanks. Yeah, no worries. Really has a lot of my best advice. Okay, so this is storing more data than before and doing worse. So this is 100% a sampling problem, right? It's actually better on Breakout, which is funny, despite the sampling problem. I think you just need more data. It's actually kind of like, okay. Okay, so the problem with sampling, right? Problem with sampling is there are a couple things. Ideally, you want to sample based on the advantage, right? That's like information gain. But advantage can get stale. You hate AI coding? Trade off an iteration speed. It doesn't make it faster, it makes it slower. Like, if you're actually a good programmer, it's kind of the same thing as, like, asking a good mathematically inclined researcher why they don't just outsource all their math to an LLM to make them be able to do their math faster, right? It's because the LLMs are really fucking stupid. There's, like, not a single thing I've done today that an LLM would have made faster. Actually, the one thing that it does make faster is what you see here, which is the single line, really stupid autocompletes that saves me typing. That let's just, for the heck of it, right? Let's just update the value function, right? Let's just update the value function. Vibe coding, learned helplessness. Heh. Yeah, I'm very happy just ignoring the LLM people and telling them they're dumb. And, like, no, I'll be waiting on the day that, like, people are actually writing, like, good, useful libraries and like, advancing research and science with these things. But for now, to me, it mostly just seems like a lot of people who are lazy and dumb and decided to not invest time in actually learning how things work, feeling smugly superior because they can now type in random sentences in English and think that they understand how things work and are useful. They're not. They're still stupid and lazy. Like, literally just, like, RL'd you into feeling like you can do things. Modify it in place. It does modify it in place, and then I added the return afterwards. So because like people expect functions to return things, I added the return afterwards. But yes, it does modify it in place. And it has to, because otherwise you have to allocate a fresh tensor, which is slower. So you can actually pre-allocate, which, to be fair, we're not really doing nicely in the way we should be doing it here, but I wrote it that way so at least I could optimize it. And it does make a difference when these advantages, the advantage tensors get too big. All right, so this should be good. That's a good slice. Ah, yeah, it's segments, isn't it? Slightly obnoxious. Try adding a little noise to the states and actions. Uh, why would you do that? That would be like an overfitting regularization thing, right? I can't think of why else you would do that. Okay. I mean, that's nice and stable at least, right? Maybe less stale data directly copy. Less stale. What do you mean less stale data to directly copy? Well, here now I know for sure the value is not stale. Oh, but actually, no, I did this wrong, right? Be self gold values. Better. Can you just update the priority? What do you mean update the priority in the tree? So the reason that it gets stale is like you're storing a cache, like you're caching a value estimate so that what you can compute advantages, right? Because otherwise you have to do the full forward pass every time you want to compute advantages. And the problem with that is if you're sampling based on advantage, like let's say you optimize one data point and advantage goes to 0, you're not going to sample it again, even though like you're going to forget that data point later on for sure. But because you haven't updated the value, you can't see that. On practice, it seems like this didn't make a big difference. We get pretty much the same results as before, insignificantly higher, I'd say. But this was definitely an issue before. So we're at 172 in breakout. There's still more to do here, though. We're storing segments based on... Storing segments based on reward is kind of just not optimal, right? Wouldn't be used. Well, because you have to update the value estimate, right? Because if you're not going to sample it, if you're computing estimate advantage based on the stale value, then you're never going to use it. You have to update the value so that when you update the advantage estimate, you actually get something recent. I'll find some hack to get around this at some point, so I don't have to do this full pass over the buffer, right? But this is for dev, and we can do this now for dev. 172. Let's do a cart pull. I'm actually not sure if this does cart pull because of the way the reward buffer works. It does it. It's just slow. Interesting. Alright, so like what portions of this... What portions of the current approach should make this slower than normal PPO? We have the same advantage weighting applied to samples, element-wise. That's basically the same loss. That is basically the same loss. I think there's some variance in it, right? Is it... You want to just store all the states? You can't store all the states. Well, what do you want? You want your data buffer to have essentially the expert demonstrations, right? What you want is you want your data buffer to have the expert demonstrations. That would be the high reward, like that's the high value ones, not the high advantage ones. Right? So what we have to do then, we have to train a separate value function, right? Wait. Hang on. We train the returns. Now, what are we training this thing against? Value function, advantages plus value. New value minus value plus advantage, I guess. Yeah, so your value function is better off. You're doing off Paul, no expert. Towards be better. We have prioritized experience replay. It's technically it's behavioral cloning. The objective is behavioral cloning, not off policy today. Based on some stuff I found. And like we actually have it learning some stuff, which is kind of crazy. Like literally this is a behavioral cloning objective, right? You're literally doing cross entropy between logics and actions. You're weighting by advantage. Hang on, am I wrong? Is the value function... Wait, what is the value function learning to predict in GP? Is it learning to predict discounted returns, or is it learning to predict... It is learning to predict just discounted returns, right? Yeah. So in that case, hang on. In that case, I know what to do, right? We update the values for everything. Yes. I know what to do. We move this up. Okay, so you're updating your all values estimate. Right? And then we do Syrian. Plus. So this is return plus value, right? Bad 189. This is how you'd want to store it, right? You'd want to use this metric. Okay, and then the only thing here now is the advantage-based sampling, I believe, right? And then how we get this correct. Okay, I mean, this works pretty much like it did before. So now we are sorting by, or now we are prioritizing by advantage. I think we also did. Let's see if this does anything. Weight it by priority, you know? Oh, yeah. Okay. Over 200 now, right? Advantages are not normalized. I think normalizing advantages breaks it, though, right? Yeah, so normalizing advantages breaks it. So we're going to need something else in place of that. Because that's like a major thing. But being able to get over 200 on breakout already, pretty damn good. We can get rid of this log ratio stuff, right? Don't need any of this. There are no more KLs. Mm-hmm. 38. Of course, there is, like, the question. It's technically possible that we're just, like, using the on-pol data anyways. And that's why it's stable. Wouldn't think so, though. Sampling by... I probably should be doing absolute value of advantage. I'm just doing advantage now, if I recall correctly. Some sort of bounce positive and negative. I think it's all positives. Let's check. Positive data is better than negative data, right? I think for behavioral cloning, you do want positive data because you want, like, it's not that informative to have a data set of negatives. You really just learn from the positive examples. No, you know what? It's currently sampling by absolute value. You're right. I mean, it's technically... Be surprised if this is that different. We'll see. Alright, I don't think that's a statistically different. I think that's just in the noise. So, okay, I guess then the question is why are we not as good as our main... Hang on, we also have tuned parameters for a totally different algorithm now, right? These two coefs first sample. Hopefully odd. It's less than 1. That's prioritized experience replay. There's nothing custom there. Okay, that's the same as before. But off-pol correction is totally bad for this, so I think this is good. And then, like, we should be able to increase update epochs now. I don't know if this actually works, but we should be able to do, like, update epochs equals 4. Right? Like, shouldn't this work now? Hmm. And it crashes. Oh, it nanned out, though. It's possible we just have to sweep this thing. We have some sanities we can do, right? We can do as a sanity check here, right? What if we run this? I mean, okay, this says that this is better. Our off data, our off-pol data version is better than our on-pol data version. So that could just be a matter of tuning. We've changed a whole bunch of stuff. Use the restroom real quick, and then I'm gonna see if I can set up, I'm gonna do a few more manual experiments, I think, and then try to see if I can set up some form of sweep. I'll be right back. This is potentially pretty novel, though. How cool would it be if this worked? I mean, there's some tests we should be able to do. It should get, if you have your sampling set up correctly, it should get strictly better with a bigger buffer size, right? Make sure we can get this to work. $200. Good-ish. So this one should do worse, right? So this kind of stalled out. It only has 1 million samples to train on. Okay. Ignoring the inefficiency of this implementation, if this does not do better, it is a sampling issue. Not bad, 267. And then this also should let me run more updates in turn. Of course, there's a lot of noise in these, right? So if it doesn't do strictly better, if it crashes, we know there's a bug. Some variety. Okay, so like this just didn't sample well. So we'll go back to 8 mil for now. I do 2 update epochs. Changes anything. Which plugin? This is Super Maven. 44. Okay, so this didn't do any better with more updates. Fix that. Oh, you know why? It's because I'm a dummy. Literally not changing anything. Or at least for that test. Okay, so not really any better, right? Just with this setup. We get to get rid of a whole bunch of the hypers though, don't we? The coefficient. Good number of parameters here to be changed. It actually does kind of concern me, right, that we don't do... We should do better with more update epochs than this, shouldn't we? At least we should be able to get to, like, some no form of sample reuse. This at least needs to be stable, right? Yeah, Nan's out. So this is like learning rate params and such, I suppose. We can tune those. I am a little curious. Behavioral cloning is supposed to scale. Those I already had these. This is supposed to scale better, isn't it? I don't see how it possibly could, because... Oh, maybe. Of course, that's going to change optimal learning rate and a bunch of other crap. Yeah, not really a distinct advantage, huh? Okay. Well, let's just do, just do the easy to sweep ones, right? We'll leave these alone. Okay. I would like to have seen I think like a slightly higher number in order to be reasonably confident. I mean, but this is kind of a crazy thing to do. So I suppose the next thing is to just think about if there are any fundamental things that make this more or less powerful. I mean, the pros here, right? The thing that this has going for it is data reuse, right? That's the key. And it's data use at the level of the trajectory segment. Compared to the PPO objective, I mean, it's the thing is the behavioral cloning objective is so close to the online objective that it should learn better with online data, right? Can we think of it that way? It makes sense, right? Because you get like a direct gradient based off of your actions and rewards. The other form of this, I suppose, would be to do explicit on policy and behavioral cloning, right? That would be the next thing to try. Would be to make it explicit, right? The separate phases. I mean, that still pairs relatively nicely, right? So this first piece is literally, it's the same, right? The only difference is they put the advantage in here versus behavioral cloning, it's 1, right? That's the only difference. So in this setup, you're not assuming that the data is better than the current policy, right? In the online RL setup, you're not assuming that the data is better than the current policy. In fact, it is data from the current policy. So some of it's better than average, some of it's worse than average, and a lot of it's pretty average. In the behavioral cloning setup, you're assuming that the data is just better than the current policy. So of course, like the naive, let's say we train a good advantage function, right? The typical behavioral cloning setup, we could use maybe the top X% of the data, whereas here you get to use all the data. In the typical behavioral cloning setup, you don't weight it by advantage, though you can weight it by advantage as well. We've found, as long as you're careful about it. We also know that behavioral cloning is a pretty strong baseline, right? When did EPG? I think this is actually not like a sample efficiency thing, right? Yeah, this is not like a sample efficiency thing. This is actually kind of more like puffer style. It just happens to be actually the fact that they report all their stuff in seconds actually pretty much guarantees that this is more a puffer style thing. So looking at this for sample F is probably not great unless they have a comparison. Yeah, this is, I think they just took some random off-pol algorithm, right? And they kind of did some similar stuff to what Puffer does to make it fast. Yeah, that's totally what they did. Okay, so I guess, like, this paper is still one of my favorites. But it's so tough to judge things like this because, I mean, they have the wall time, but they cut samples, so you don't actually know, like, can this do better than Puffer given the same amount of wall clock on, like, one of our tasks? Like, a few thousand steps per second, if I recall. Yeah, I mean, this is a good paper. It's just tough to compare here, right? Honestly, the biggest improvement was just swapping the architecture, funny enough. We could pretty easily do architecture stuff. I'll look at sample efficiency. The thing that's like obnoxious, I think, is just that the sample efficiency setup, at least it is normally defined, as a hardware inefficient setup. Guess it doesn't have to be, right? Just like train reasonable batch sizes. Don't have a ton of parallel ends. But then you use more compute on the train pass anyways. Fire a replay buffer. It's actually kind of feasible. It's actually kind of feasible. 5. Hmm. It's going to be very difficult to beat like our optimized on policy setup with this, frankly. It could happen, I'd be surprised. I would like to see how well this does. I wonder if it was mistaken to try to do the on policy setup. Well, actually, you know what? The other thing that just is tough, um, it's fully an artifact of the LSTM, right? Yeah, because we have an LSTM, right? You get off policy, you mess up your LSTM state. Like, regardless of the algorithm you use, you're gonna mess up your LSTM state a bunch. That's not great. It's actually kind of a motivation for transformer-based architecture, isn't it? Efficient at smaller batches. Possible. else get messed up with that? Not really, right? Really. TM is just to deploy. But it actually probably, the LSTM architecture is probably driving me towards on-pol more than I normally would be. I think that the key finding here, right? And this was the key finding from a couple of days ago at this point. But even doing a super, super simple behavioral cloning thing with just the top whatever percent of your data, even just by reward, that already gives you qualitatively and in some very important cases better behavior than doing SOTA on policy learning. Very difficult to get it to solve like the full tasks. Sufficient motivation to include it though in some capacity. I think the formulation I came up with today is quite good for the buffer. Right, the buffer being stored by reward plus terminal value instead of by advantage. That's really how you would do it if you wanted to build up like a good data set over time, right? So I think we'll try tomorrow. We'll try to do it in phases. We'll try to do our current on policy with this extra like additional gold data set, and we'll do it like as an additional step. We'll compare that. That should be a lot easier to get to work. Unless this thing just happens to crush it, which I doubt. This break been on 23 runs for a while, hasn't it? How'd I know? The heck is this? Somehow managed to screw something up there. Want it to see. 816. Start on this now or no? I suppose I could start on it now. I don't want to just have all day tomorrow to do it, though. For a bit. I mean, that should have to work, right? And I think that the mistake I made last time was I didn't train the value function when I tried this before. That does leave us with an annoyingly complicated algorithm, I guess, but I think we'll be able to strip off things we don't need over time from there. Okay, I think that's what I'm going to do. I think I'm going to call it early. I'm going to get myself an early dinner. I'm going to come back tomorrow. And we'll have a full day to just crank this stuff out. And hopefully by the end of tomorrow, I have at least a usable version of behavioral cloning integration. Cut off that. Working later. Well, I suppose I'm biased towards thinking that there is a very simple method that should just work. I shouldn't just have to keep bolting stuff on to the algorithm. The behavioral cloning one, it's not that bad, I suppose. I was hoping we would get like one algorithm, right? That could do both. Actually, I think that this will be the last question I'll have for this stream if anybody has any ideas today. So the setup here, right, is that you have a whole section of researchers who've been aggressively optimizing for sample efficiency, working on off-policy algorithms. And to them, like, compute is free, right? Like, compute is just free. So they've been, like, writing these ridiculous, not that great algorithms, but that let you infinitely reuse data. And therefore, like, by doing that, you can get pretty good. And then there's a bunch of on-policy research, some of which is misguidedly on sample efficiency, but a lot of it's just like, can we get the thing to learn fast? That's what we do in Puffer. And this works very, very well. The problem is, at least as far as I've seen, it doesn't seem to me that you can just take one of the best off-policy algorithms and just, like, run it fast on a ton of fresh data and have it do as well as our on policy. And likewise, you know, we can optimize our stuff for sample efficiency a bit, but we can't just go match the sample efficiency of algorithms that reuse data. So how do we bridge this gap without doing something horrendous? Right? That is the key research question for right now. I keep finding skeletons in the closet like frickin' everywhere with this stuff as well. There's no code for this thing, is there? There is code for this thing. I mean, I guess one thing I could do I could take some time. I could actually assign this to one of my stupid link. Why can't I copy a link? This is good. Oh, this is super simple. So, maybe what I should do is I should take this and like run this on one of my Puffer environments. Like a relatively simple script. I didn't know that this had code released. Maybe we just hack this, right? So what I would do is I'd take this thing to re-optimize hypers as well as the problem. I was trying to figure out, right, like if I take this thing and I run it at like puffer batch sizes, if that still does something. It's actually kind of tricky. And actually, come to think of it, like the thing I was thinking about doing tomorrow, does that even make sense? Like, yes, technically it allows you to leverage some off-policy data through behavioral cloning, and I think it would improve our on-policy stuff in a few cases. I don't think that gets you sample F though, right? Maybe it does. I guess the idea would be that you do most of the steps on the behavioral cloning objective. A lot of work to do, frankly. Okay, well that's interesting at least. Hmm. It'd actually be really tough to like do apples to apples of like any of these. Like let's say that we get BTR code. Basically have to get it into Puffer, the whole thing. Hope to not screw it up. Is there a safer way I can like test this? I mean, yeah, right. I would just set the batch sizes to something crazy. Use Puffer networks. See how quick it is and how well it does. There's not going to be an optimized implementation. Well, actually, that's kind of okay, right? I'll run it for if I run it for the same number of steps. I assume that I can optimize it to that point. It's good. That might be a more practical thing to do tomorrow. Regardless, I'm going to need a few more days to spend on this research before I really get something, I think. I think it would also be interesting to see if I threw this on Neural MMO, if it does the same thing that the behavioral cloning objective did, which was to like target leveling up very, very early on. I do think though that this is like a weird in between. Literally half of the perf from not half. See? Yeah, half of the perf is just the network architecture. Bunch of other tricks. Lower. Well, it is Friday. I'm tired. Been doing crazy research all week. Huh. I want to get this run to be at least stable, actually. It would be good to have this thing actually tuned correctly. Get us, like, some interesting results. Okay, though. I'm gonna just call it here and go get my dinner. So, thank you, folks, for tuning in. Um, I will be back likely first thing in the morning. Interested in the research generally. Puffer.ai for all the things. Or the GitHub to help me out for free. Discord if you want to get involved.